Bismillahirrahmanirrahim. Hello everyone. Welcome back to the another tutorial. So in this tutorial, I will cover the chapter DC motor, that is chapter 18 of Honda MCQs. So in today's tutorial, I will cover MCQs from MCQs 11 to MCQs 20. So the first MCQs is the speed of a series wound DC motor can be controlled by a shunt speed regulator, cannot be controlled by a diverter, increase as flux decrease, increase as armature circuit resistance increase. So actually we have a well-known formula, and that is your N is directly proportional to back EMF. This is the motor, so we will use back EMF divided by flux. And your back EMF is equal to, in case of motor, that will be equal to V minus IA into RA plus RF divided by flux. IA is the armature current, RA is the armature resistance, RF is the field resistance. So actually in series motor, my IA is equal to IF. And your IA depend on load. It depend on load. So on light load, your IA will be less. So if your IA is less, then it means your IN will be high. So you can say that my N have inverse relation with armature current. So here one MCQ is the speed of the series wound DC generator increase as the flux decrease. So increase as the flux decrease. So yes, that is the correct option. Increase as armature circuit resistance increase. So if you increase the armature circuit resistance, then it will decrease the speed. So your N will be inversely proportional to the armature resistance, or you can say that field resistance. If you increase the field resistance, then it will decrease the speed, or are inversely proportional to IA or RA or RF. Okay, next MCQs is following controls are considered for DC motor: control of flux, armature resistance control, supply voltage control. Which of the above controls plays significant role in the speed control of DC motor? So as I already discussed in last MCQs, that my speed will be directly proportional to EB divided by flux, and my EB will be equal to V minus IA into RA plus RF divided by flux. So the speed can be controlled of flux. Yes, it can be controlled by the control of flux. Armature resistance control, yes. Armature resistance control. Supply voltage control, yes. Supply voltage control. So 1, 2, and 3. So option D is the correct answer. Okay, next MCQs is the speed regulation of a DC motor is high speed divided by lowest speed, no load speed divided by full load speed divided by no load speed minus full load speed. So that is the no load speed minus full load speed divided by full load speed. So D is the correct option. And speed regulation tell you about the speed variation. If speed regulation is high, if speed regulation is high, then it means that the variation in speed is high. So if speed regulation is low, then it means you have a approximately constant speed. And ideally, we should keep it as low as possible. Okay, and if the speed regulation is 0%, then your no load speed will be equal to the full load speed. Okay, next MCQs is A DC motor having full load speed of 800 and speed regulation of 8% will have no load speed of 864 RPM. RPM means revolution per minute. 832 RPM, 768 RPM, 736 RPM. So actually, as I already discussed in last video, that we have well-known formula that is your speed regulation is equal to no load speed minus full load speed divided by full load speed. Okay, so speed regulation is given to me that is 8%, so it will be 0.08, and that is equal to no load speed is mm, not given to me, so that is unknown u minus full load speed is 800 divided by 800. So this will be 0.08 times 800 will be equal to 64 plus 800. This is unknown. So your unknown, your no load speed will be equal to 864 RPM. So is there any 864? Yes, option A is the correct answer. Okay, next MCQs is for a series motor, if TA be the torque and IA the armature current, then which relation is valid for the condition before saturation? So actually, in we have for DC motor, we have a relation between torque, armature current, and flux, and that is your torque will be directly proportional to armature current and flux. So in case of series motor, the IA will be equal to flux. So if you increase the armature current, then the flux will get increased. So your TA will be directly proportional to IA square. So option B is the correct answer. TA is directly proportional to IA square for series motor. This is only for series motor. So it means that if you increase the armature current 2 times, then your torque will increase 4 times. Okay, next MCQs is in a DC series motor, shaft torque is less than the armature torque due to stray losses, eddy current losses, hysteresis losses, all of the above. So the correct option is option A, that is the stray losses. Stray losses is the losses like bearing losses, or you can say that fractional losses. This type of losses is also known as the mechanical losses. So if the mechanical losses get increased, then your torque will get decreased. Output torque will get decreased. So the shaft torque, yes, the shaft torque is less than the armature torque due to stray losses. Yes, stray losses is the correct answer. Okay, next MCQ is DC motor with self-loading properties is series motor, shunt motor, cumulative compound motor, differential compound motor. So actually the correct option is option D, that is the differential compound motor. So let's explain it a little bit more. So actually the in differential compound motor, your flux, yeah, you can say that your net flux is equal to, this is shunt, minus flux of series winding. While in case of cumulative compound motor, my net flux will be equal to flux of shunt winding plus flux of series winding. So you can say that in cumulative compound motor, the series speed enhance the shunt speed, while in case of differential compound motor, the series speed oppose the shunt speed. So due to which the field flux get decreased. But one question which come in your mind that if the net flux decrease, then the speed should increase. But this is not too much increase as we expected. So you can say that the speed regulation is good. Speed regulation of differential compound motor is round about 5%, while the speed regulation of cumulative compound motor is round about 20 to 50%. So the speed regulation of differential compound motor is good. So, but it is not as good as like the shunt motor, like the speed regulation of shunt motor. So in a differential compound motor, we have constant speed, but we have low starting torque. While in case of cumulative compound motor, we have high starting torque. So there is a low starting torque, so there will be a sort of speed instability during starting. So it is recommended to start it as like a shunt motor. At starting, start it like a shunt motor. How you will start it like a shunt motor? You will short circuit the series feed. If you short circuit the series feed, then it will become shunt motor. So here we have armature, here we have shunt feed, and here we have series feed. So if you short circuit this series feed, then it will become shunt feed. So start it like a shunt motor because during starting there will be a high armature current. So due to high armature current, or you can say that due to high starting current, the series speed of differential compound motor may overbalance the shunt feed and cause the motor to rotate in the opposite direction. So this is the reason behind this, that why we doing short circuiting the series feed during starting. Okay, next MCQs is the current drawn by a 120 volt DC motor of armature resistance 0.4 ohm and back EMF 120 volt is 10, 20, 1, 12 ampere, 120 ampere. So actually, in case of motor, my supply voltage will be equal to back EMF plus armature resistance, armature current. So the supply voltage is given to me, that is 120 volt. EB is given to me, that is 112, plus armature current is unknown, I need to find it, and armature resistance is given to me, that is 0.4 ohm. So 120 minus 112 divided by 0.4 is equal to IA. So if I use calculator for this, then my 120 minus 112 is equal to 8 divided by 0.4, that's equal to 20. So your IA is equal to 20 ampere. So option B is the correct answer. Okay, next MCQs is, if the load current and flux of a DC motor are held constant and voltage applied across its armature is increased by 5%, the speed of motor will increase by about 5%, reduce by about 5%, remain unaltered, depend on other factors. So actually we have a well-known formula, that is your speed is directly proportional to EB divided by flux, where EB is equal to V minus IA into RA plus RF bracket close divided by flux. So the question is, your load current and flux of a DC motor are held constant. So it means this portion is held constant. So if this is constant, then it means that if you increase the supply voltage, then it will increase the back EMF, which will increase the speed at the same amount. So the speed of the motor will increase by about 5%. If you increase the supply voltage by 5%, then the speed will increase by about 5%. Okay, next MCQ says a DC motor developed a torque of 140 nanometer Newton meter at 1400 RPM. If the motor now runs at 1000 RPM, the torque developed will be 140 Newton meter, 1000 Newton meter, 71 Newton meter, 51 Newton meter. So actually, uh, here in book, the correct option is option A, 140 Newton meter. But I think this is wrong because we have an inverse relation of torque and speed. So your torque 1 will be equal to N1, torque 2 will be equal to 1 by N2. So your T1 by T2 will be equal to N2 by N1. And T1 is 140 is equal to N2 is 1000 and 1 is 1400. So from this, your T2 will be equal to 196 Newton meter. So I think this is the correct answer. So if you have any solution of this MCQs, so you can explain that in the comment box. Okay, so this is the end of this video. Thanks for watching. Allah Hafiz.